In this video, I want to talk about labor supply and the welfare economics of labor supply, which is a little bit complicated because it affects both income and a valuable consumption good that is leisure. So the first thing we're going to start out with, we're going to think about the trade-off between labor supplies. Let's just assume that we're talking about daily labor. And so a consumer can either dedicate 100% of their time to leisure, which would be 24 hours there, or they could dedicate 100% of their time, that'd be hard, but dedicate 100% of the time to work, which would be at the far right end of this axis. On the vertical axis, we can think how much money could they make? Well, if they had a wage rate of $10, they could make $240. If they had a wage rate of $20 per hour, they'd be able to make $480, etc. And so that allows us to think about the budget constraint in this space. So they can basically have the opportunity of choosing between a 0 hours of work and making $0, or at a wage rate of $10 an hour, making $240 in a 24-hour period, or $480 in a wage rate of $20 per hour. Now, let's think about preferences. So if we impose on this graph a difference curve in which the consumer has preferences, and they like leisure, and they really don't like to work. So that our space is the utility is increasing as we move to the left, but it's also increasing as we move up, right? More money consumers tend to like. So you can imagine that we have an equilibrium, an optimum for the consumer at about 8 hours or 6 hours of work. In this case, at the $10 per hour wage rate, at the $20 per hour wage rate, let's assume that they are excited and they work a little bit more, so they now are working 8 hours per day. If the wage rate increases even further, maybe they say, well, now I'm happy and I'm satisfied, and so I'm going to actually reduce the number of hours that I work. And so they reduce the number of hours back down to 6 hours at $30 per hour. But you can see that 30 times 6 and 20 times 108, they're still making more money even though they've reduced the number of hours that they're working. So this is, of course, a solution to an optimization problem where they're maximizing their utility, which is a function of 24 minus h, that is the number of hours that they have for leisure, and their consumption goods Q, subject to a constraint where we have M bar, which is an exogenous income, plus W times H, that's their earned income, has to be greater than or equal to the amount of money that they spend on consumption goods. This leads, of course, obviously to the indirect utility function, which is also in that same space, P, W, and now I've changed to more general notation, tau, which is what is used in Just, Hewitt, and Smith to define the total hours available to work. Now, we can plot this then on a graph in the space of wage rate versus hours, and we have, at $10, they chose to work 8 hours or 6 hours per day. At a wage rate of $20, they chose to work 8 hours per day. And at a wage rate of $30, they reduced their hours back down to 6 hours. So you can imagine a Marshallian demand curve, which is going to be like this. And this is simply the solution to this statement that H of WP M0 is argmax, that is the solution to that maximum problem of 24 minus H of Q, subject to our budget constraint. The important thing to note about this is that labor in this space, as presented here, labor supply curves will always have a backward sloping portion. Always. Okay. Eventually, you get to the point where if you're making $1 million per hour, people are going to reduce their amount of the amount that they work. So that labor supply curve is always going back, as defined in this space, where the consumer is simply thinking about leisure and other consumption goods as the two things that enter into their utility function. So we can now let's think about this in Hicksian space. So we're going to look first at the utility function associated with a $20 per hour wage rate. Now let's ask a different question. How much exogenous income would we require to give the consumer to get them up to that level of utility associated with the $20 per hour wage rate if they only had a wage rate of $10 per hour? So if that were the case, we'd have the budget, the slope of the budget constraint would be at the same as the $10 per hour wage rate, but we'd have to give them additional money, right? We'd have to increase their exogenous income in order to put them back onto the original $20 per hour indifference curve. On the other hand, if we had a $30 per hour wage rate, we'd have we'd have to actually take away money from them in order to get them back, reduce them back onto the indifference curve associated with the $20 per hour wage rate. So as we rotate around, and we can even push this further and go up to a $40 per hour wage rate, you'll see that the slope of the $40 per hour wage rate is even steeper, and we'd need to take more money away from the individual. These lead to the Hicksian demands as specified here, right? For a $10 per hour wage rate, for the Hicksian demand associated with the $20 per hour utility level, they would only work $4 per hour, 4 hours in order to get to that level of utility. That increases to 8, then 10, then 12. What we've just gone through is the solution to the expenditure function problem. That is the minimizing over W times H times PQ, subject to the constraint that you're able to accomplish the reference level of utility U bar. So how much can we reduce their expenditure to get up to that level of utility, contingent on having a particular wage rate? And so that gives rise to the expenditure function as a function of this, and that correlates to the vertical axis on this. The Hicksian demand curve is then simply the partial derivative of the expenditure function. I'm sorry, the Hicksian supply curve, in this case, the Hicksian labor supply curve, is the derivative of the expenditure function with respect to the wage rate. What does that look like? Well, that's an upward sloping curve. In this case, it goes from 4 to 8 to 10 to 12, coinciding with the levels that we saw in this here, in this graph here. So unlike the Marshallian labor supply curves, which tend to have a backward sloping portion, the Hicksian labor supply curves are always upward sloping. Why is that? Well, it's because our indifference curve, we're simply rotating along the indifference curve. This is never going to lead to a tendency that is backward sloping if preferences are consistent with standard axioms of rationality. We can now, since we know that the Hicksian demand curve is equal to the derivative of the expenditure function with respect to the wage rate, we can now use the Hicksian demand curve to recover the welfare effects associated with a wage change, right? The wage change is going to be the area behind the Hicksian labor supply curve, this gray area here, as we go from 20 to 30. So unlike the Marshallian labor supply curve, which would give in this case, a quite wrong answer, the Hicksian labor supply curve will give us the correct measure of the welfare consequences of a wage change. So that's the economics of labor supply. Very simple expression. Hope this helps.